Okay, hi everyone, and welcome to my little talk about Argo Workflows and talk about how we as a user can use Argo Workflows to consolidate almost all of your workflow needs. First of all, a little bit to myself. I'm Sebastian. I'm a distributed systems researcher and DevOps person from Giessen University in Germany. And we do all kind of stuff with cloud, especially from a compute perspective, because I'm a bioinformatician, and so I do really heavy number crunching for sequences and all this kind of stuff. And so I need quite performant compute capabilities. Let me guide you a little bit through the agenda today. In the first session, I will a little bit introduce the background and what we are dealing with and why we came up with our ideas. Then a little bit, we will talk about our problem and how Argo Workflow might solve this problem, so the solution for that, and then a lot of examples for implementation guidelines and how we implemented this in a quite naive but maybe quite approachable way. And afterwards, we will go a little bit through our results and what we achieved with this and so on. A little bit of a background. So our university, so in Giessen, you see here in the middle of Germany, is part of a larger network in Germany where we provide a community cloud for life science researchers. So researchers can come to us and get storage, compute, all this kind of stuff, and they can use that to make whatever they want as long as they have a research focus, and they get it totally for free. So they can say, okay, I want 10 VMs to do some number crunching or something like that, and then they come to us and they get them as they like. We provide in there an OpenStack environment. We really heavily invested in Kubernetes, and so this is the reason why we talk about Argo Workflows here. And we also have quite a few HPC instances and also VMs for users to use when they just want to have a single VM to do some compute or to deploy a service there. And our Argo Workflow journey started around 5 years ago. Actually, I wrote my master's thesis about this topic. It all dealt with how can we use Kubernetes for compute jobs, how can we utilize the whole Kubernetes infrastructure and especially Argo Workflows for our compute needs. We were quite successful with this. We have a few, I think almost 12 clusters now up and running that do some number crunching with Argo Workflows. The largest one has around 5K cores, so it's quite a large Argo Workflow cluster. And if I talk to people that do more with Argo Workflows under the hood, they say, okay, this is quite large. And we also have some jobs or some workflows that run quite long, for days or weeks, and also some workflows that have quite a huge number of pods. So I think the largest I've seen was around 30K pods for Argo Workflow, which was quite an accomplishment, but also quite a struggle to get it running and working in our environment. Primarily we use this for analysis workflows. So users come to us, bring their data, get some analysis, and afterwards they get some results, visualizations, all this kind of stuff back. And one really useful pattern we developed here was the pattern here on the right, where you have the Kubernetes cluster, a web front end that has some website where user can just upload their data. And this is all backed by a really simple API. And this API talks to Argo Workflow cluster and schedules Argo Workflows, all based on workflow templates. I think there's also, the next talk is also about workflow templates, I think in the other room. So when you want to learn more about workflow templates, then you can look at this talk. And by using this, we have a quite approachable system where we can provide on-demand compute for users. And our API backend is really that simple. It's just an API and some calls to the Argo API or to the Kubernetes cluster to schedule the workflow and retrieve the results afterwards. What were the reasons why we chose Argo Workflows? I will just quickly skim a little bit through here. It's really flexible. You can do almost everything with this. It's really extensible. There's the plugin system, workflow templates, which are really nice to have building blocks for your workflows. You have easy API access, and you can also, via labels and annotations, store some data with your workflow, which makes it quite convenient because then your backend doesn't need to have a database. You can just put everything in Kubernetes and store it there as long as it's not something confidential or something security relevant. It's almost fine to do this. Then the event system is also quite, so via Argo events and scheduling from external sources and event triggering of event-triggered workflows, it's also quite convenient to have because then you can have more deeper automations with the external world like message queues and so on. As I've said, we have deeply invested in Kubernetes, and so having the almost de facto standard workflow engine for Kubernetes as Argo Workflows is there's almost no other choice to do here, so this is also quite a big positive for using Argo Workflows. And there is a larger ecosystem which makes it quite convenient. For example, there's the Python library Hera, and there are the Argo CD integrations, Argo rollouts. The previous talk was about that, and so it's quite convenient to have something in place. Overall, we like Argo Workflows quite a lot, but our reality looks a little bit different. We have many users. Most of these users are PhD students that come with their own really nice ideas and bring their own some kind of workflow engine with it. And so we have a really large patchwork of so many workflow engines, so many tools and environments we all have to manage. And most of them will get lost after a little bit of time, but many of them we need to maintain even if the person who developed it initially is long gone. And so we have quite a large burden to manage older systems that are already in place and that we now need to either migrate or integrate in our existing infrastructure. And this is a little bit so the promise of a public cloud. So when you go to large cloud providers, you get everything under one roof, everything together, and everything as a nice packaging with a nice API. But when you do this on your own, you do have something like that, where you have all these kinds of tools that are specialized for one specific case or one specific topic, but are not really that easy to integrate and introduce a lot of burden to people to maintain. The pros are obvious. You get independence and sovereignty when you do this because, okay, you have everything in your own hands and you can build the system you want to have. You can have really specialized solutions here. You can have much greater data protection when you want that. But the cons are also really large. The mental overhead to maintaining 10s or 15s or 20th of workflow systems in parallel is quite huge, and this needs large human resources. This needs many resources that are developers for a specific tool and specialized people that aren't really that easy exchangeable. And the onboarding time is really large. So when a new person comes to us and new PhD student starts their work, getting them onboarded in the maze of tools we have already in place is quite tricky and quite hard. So then I think 2 years ago we had this idea. Can Argo Workflows be a universal scheduling engine for everything we do? And the initial answer to this question was maybe. On a second thought, it was maybe yes. So then we had another thought and thought, okay, how can Argo Workflows do this? So what would be needed to have Argo Workflows as our universal cloud managing engine? So we came up with two strategies. The first is migration, so put the thing we have and make an Argo Workflow from it. And the second strategy is integration, because there are quite a few things we can't really that easily migrate because there are requirements, there are some additional boundaries we can't really break to make an Argo Workflow out of everything. And so we did both. So for strategy migration, okay, it's quite simple. You take the workflow you have and try to mimic or integrate this in an Argo Workflow. Just write your Argo Workflow YAML, possibly use a workflow template for this, because then you have something reusable that you may integrate with other things and may easily be adaptable. I think this is quite straightforward, because converting something is always an option, but it is also the most costly option, because you need to put heavy work into it, and you need to understand the previous developer that developed the original workflow to make it work in the same way it was working before. And the second strategy is integration. And integration just keeps the system in place that already is in place. Don't touch it. Just use Argo Workflow as your trigger to trigger the workflow and monitor its status, and afterwards collect the results or put the input data there, run the workflow in a main step, and afterwards finalize and get the data back to your cloud environment. And this works for some of these cases. This works quite well. It's a little bit naive, and it also has some drawbacks which I talk about a little bit later, but I think it's quite a good way to do this. So we came up with a little bit of a decision matrix. Is it easy to are there hard requirements for the existing system? For example, regulatory requirements, or does it need to be the existing system? I think when the answer is yes to that, there is no other option than integration, because you can't migrate it because you have hard requirements. For really complex workflows and really finicky and niche workflows, it's also quite tricky to do. And so then integration may be also a better strategy. Do you have sufficient team expertise for the existing solution? If you have 10 engineers working on it, I think there's no real reason to migrate it. But if there's only one PhD student that will be gone in 3 months, then there is quite an emphasis to migrate it right away, because when he will be gone, I think the whole pipeline might be gone. Yes, and then there are quite a few other things. Is your pipeline portable? Do you have containerized pipeline already in place? Because migrating everything to a container is also sometimes a little bit tricky. And so then there might also be quite an effort to integrate it more than migrate it. We try to migrate some of our HPC workloads. So we have a large SLURM cluster in our institute, and we quite successfully rewrote many of our workflows to Argo Workflows, because they were really straightforward. Data in, do something with the data, results out. And this can be really easily mimicked with Argo Workflows, and there are no real challenges. I think the main challenges we had here was a shared file system. So our SLURM cluster has one shared file system where every node can put data wherever they want. They have one volume where each node can access the data. And when you do this with Argo Workflows, you might not have this, or you need to ship data to an S3 bucket and retrieve it. You could have a read-write-many volume if you like, but I am not really convinced that this is the best solution from a performance perspective. Shared permissions are also sometimes a little bit annoying to have, because then you need to migrate all your users that do stuff with your HPC system to your Kubernetes cluster, and you need to mimic your role-based access control and all this kind of stuff. In our internal system, we also have some internal database up and running. which don't really have access, or our Kubernetes cloud infrastructure doesn't really have access to these databases, and so there were also some migration efforts. And specialized hardware is always a problem. When we have some nodes that have FPGAs, GPUs, and all this kind of stuff, we need to have the same capabilities in our Kubernetes cluster. And for some really specialized hardware, there is not really always an option to do this. Okay, so now I've talked a little bit about migration. I think it's quite straightforward because just rewrite it in Argo. Integration, I think, is also quite straightforward because we chose a really naive way. So here we have a snippet from a template section from a workflow where I just focus on the steps or on the dark steps I developed here or integrated here. I just have some input artifacts from some cloud environment, from some S3 bucket or whatever. Then I have a really, really simple Debian or Alpine or whatever image that just puts the data in the HPC environment. I think it's quite easy to do, and it's really naive and might not be the performance optimal way, but it is the easiest way to do this. And so it has really low maintenance and developer effort. In the second thing, I just run my SLURM command. I just do sbatch and run my SLURM command. And with the --wait parameter, I can trigger the workflow to wait for completion. And afterwards, I have a proxy workflow in my Argo cluster that mimics the current status of my SLURM workload. And so I have a system that I can use for that. And in the finalized step, I just get back my data, my results from my shared environment, from my shared HPC environment, and I just get back my results and put it back to S3 or wherever you want to have your results back. When we look at stuff like Apache Airflow, we had quite a few Apache Airflow workflows, and what is quite trivial when we had lots of Apache Airflow workflows that just used some Python functions and did some stuff with Python functions. And when we look at Hera, which is a Python library that can be used to make and build and run Argo workflows, then you can see that migration here is quite trivial because in most of the cases you can just reuse your functions and just use the same functions you already have in place. You only need to change a little bit on some places, and it's really easy to migrate. It takes 1 day of time, and then you have most of your Apache Airflow workflows migrated here, which is quite convenient. And integration is a little bit similar to the SLURM case. So we also have an Airflow workflow or an Airflow DAG that we already registered in our Airflow instance. Then we just run it and wait for completion. Just poll it every 5 seconds and get back your results afterwards. Which is also a naive way to do this, but it's a quite convenient and quite straightforward way to do this. And there is also a Spark example. I don't really want to jump really heavily in this Spark example because there are quite good blog entries from the PyKit people. There was also, I think, 2 years ago a talk about that. So there are already lots of resources in place that talk about how Spark integration with Argo Workflows can work. Mostly it revolves around creating a resource. So there is the Kubeflow Spark operator, and using this you can just create a Spark application resource and monitor its status, which is quite convenient and quite easy to do. And we also migrated some of our functions. We had previously some of, we had mainly used Apache OpenWhisk for this, and we had some mostly Python functions. Again, bioinformaticians love Python. And in this regard, we had many Python functions, and migration was quite easy because we now use an UV template. UV is a quick and easy extension, or you can replace pip with this. And what's quite nice about UV is that you can create inline dependencies in your script And so it builds your environment when it gets run and tears everything down afterwards, and you don't need to create specialized container for this. You don't need to deal with conda environments and all this kind of stuff, which is quite tricky to do when you have finicky Python environments. You can also do this with other programming languages, Rust, JavaScript, whatever. There are quite a few examples for this as well. And we were quite happy with this because we could have a workflow template for run something in Python. And it was easy to do, and we have one template that we can just reuse to do something in Python. And the user just needs to provide their script and the header with their dependencies they need to do their stuff. In the end, you get something like that, a unified developer experience. You get your Argo dashboard, and you have all your workflows and everything you have at hand in one neat and easy to maintain UI. And for us, it's quite important because we want to track KPIs, we want to have metrics and all this kind of stuff. And so it was quite hard to maintain all these kind of UIs and all these kind of systems spread around our infrastructure. And now we can have a single entry point where we can see who is running what. And then we have a little bit what is promised by the large cloud providers, everything under one roof. There are a few limitations and challenges here. If you have some workloads that need to have low latency, then maybe Argo Workflow might not be the best fit here. If you have some stream processing environments that constantly needs to process a stream environment, then it's also a little bit challenging. You get some performance overhead here because you do some work, especially from the integration part, you do some work where you don't need to have done some work in the first place, but you get something back from this work. As I've said, specialized hardware is a little bit of a problem, and maintaining and managing multiple Argo Workflow instances are also sometimes a little bit tricky because it is not that easy to have a federation of Argo Workflow instances together. So in the end, Argo Workflows for us could be used to have as a unified scheduling engine. Workflow templates were really, really beneficial for that because it made onboarding time quite easy because we had a collection of workflow templates for all the stuff we want to do, and so users just need to use them when they are already in place. And Kubernetes can replace, at least in some ways, our HPC workloads we had previously in place. A little bit as an outlook, I have a little wish list to Argo and what I want Argo Workflows to do in the future. So better synchronization between different Argo Workflow clusters would be quite convenient. So having a proxy Argo Workflow cluster that just mimics the state back to the initial Argo Workflow cluster would be quite convenient. A little bit smarter request and resource limits would also be quite convenient because we had the problem that some of our workloads were unpredictable in their resource requirements, from 10 gigs to 100 gigs of RAM, and everything in between were used by them. And so having this a little bit more fine-tuned based on the previously requests would be quite nice. Because we have some clusters where many users are using this, there is also this project called Q, where you can have a batch system or a batch scheduling system in your Kubernetes cluster. And integrating this with Argo Workflows would be quite nice because then you can have a more deeper prioritization between the jobs from different people and different priority levels. And a better data management integration with Fuse would also be quite convenient, but we are working on this. We are currently developing a tool that does a little bit of Fuse magic in your Kubernetes cluster, where you can have a persistent volume claim that just uses the Fuse mount internally to mount an external storage solution. Yeah, and there's also my personal wish list, but I want to do all my stuff in Argo, but I'm nowhere close to do this, but maybe in the future this will be done. And I want to have some more tools that automate the translation process from the one to the other, especially for the trivial examples like Airflow to Hera, I think it could be quite convenient to have some conversion here in place that will be automated. And yes, when you want to share some feedback, there is a QR code for feedback and also the session slide. And when you have any questions, contact me. And we also have a poster presentation on Thursday. So when you just want to step by, we can talk about this, but also on our poster topic where we try to do a little bit more of data management. And thank you for attendance.